so it's working. 5.3, we are still on graphs of rational functions, and we're finishing example 1. Example 1, we've got the holes, so there's no holes, asymptotes. Restrictions always comes from, so for the restrictions, you're looking at what numbers you're restricting, which is usually the denominator again. So it kind of repeats itself from the vertical asymptote and the holes. So we'll look at the restrictions in a minute or in another example as well. But you're looking here to say that the vertical asymptote can equal here and also the holes, right? That's my restriction. X-intercept, Y-intercept, we already did that. You're titling it. You don't have to tell me what it equals. You're saying X-intercept this, Y-intercept this. You don't have to show me the work. Like if you do this in your head and say X-intercept, none, Y-intercept 2/3, right? That's fine. Positive, negative interval, I did it from the graph of it. Now, the approach. The approach is our last part. So this topic here is called approach. So this is the word we're going to use when we talk about this. For every limit, there's two approaches for every for every asymptote, there's two approaches. Right? So for every asymptote, there's two approaches. So for instance, for a vertical asymptote, for my vertical asymptote, I have two approaches. So when you talk about that dashed line, so this dashed line here is my vertical asymptote right here, right? So this vertical asymptote. So with this one right here, I'm talking about as you approach that yellow line, there are two approaches. What that means is that you can approach this yellow line from the left side of the graph or the right side of the graph. So there's two ways to approach it, left side or right side. You're going to write that down, and we're going to use something called a limit. Limit means really close. So limit for us, this is short form for limit. Okay, so short form for limit. Underneath it, we're going to write lim, and then we're going to say X and then an arrow. So that's an arrow approaching something of f of x. Okay, so this is how we're going to write it. So what this is saying is I want the limit, so get really close. So limit for us means really close. The limit as x approaches, x is walking towards something on the graph of the function. So limit means close. So for us, we're just doing really close. Okay, so really close. Limit for us is really close. We'll talk more about limits later on. So if you do take the calculus course, we begin fairly early on in the course, we talk about limits. So we'll explore that more and different types and all that. For us right now, we just want you to get used to how you write it for an asymptote. Just because before I would teach it, and you would write it, but then I'd have to unteach you how you write it if you take the calculus course. I'm like, stop writing it that way. I need you to write with limits. Stop writing it that way. Write it with the limit. You'd be like, oh, shoot, because you kind of get into a pattern. So right now, we're just going to have you write it with the limits, even though we're not talking about the whole topic of limits yet. Okay? And all it is that extra LIM, which stands as short form for limit. And you say limit of that. Okay, so here, so for this vertical asymptote, there's two approaches, which means you're approaching either from the left or the right. You want to describe it in two ways. So the way we're going to do this is, so for my vertical asymptote, we're going to write the approach. Okay, my approach is going to be, and we're going to do this. I'm going to write the limit, so that means I'm walking, getting close to x as I'm walking towards -3. Does that make sense? I'm walking, x is getting closer to -3. So I'm walking the graph as I'm approaching -3, okay, of the f of x, and you have to tell me what the graph is, f of x, g of x, y, whatever it is, right? So tell me what the function is. So always make sure, people always focus on the rest of it and they forget to tell me the function, right? So tell me the name of the function, f, g, y, whatever, right? So usually we use f of x. And now I want to distinguish, because remember I said there's two approaches. Am I walking to the left here or to the right? So you want to describe that? So for math, we put a little negative here above that exponent. So look, it's this. Limit as x approaches -3 from the left or the right. So that's right, and that's left. And then the f of x kind of goes beside f of x. Sorry, my f of x looks like it's above it. It's kind of beside it. I'm going to actually fix that a little. it looks like it's too close. So I usually do f of x like this, kind of aside. Okay, so the limit as x is walking towards -3 from the left side of -3. So what is happening on the left side of -3 as I'm walking towards this yellow asymptote? So this here, right? So this is my vertical asymptote will be this yellow here. As I'm walking it from the left side, I'm whoosh, falling downwards. I'm falling downwards, so you're going to tell me down, but you're not going to use the word down, right? You're not going to use the word down. You're going to say equals -infinity. Equals -infinity. So you're heading whoosh down forever and ever and ever, falling down, okay? Then for this one, as you're walking towards the right side of the graph, you're heading up forever and ever and ever and ever and ever. So that's going to be infinity, right? And that's the right way to write it versus you writing it a different way and then me saying in calculus, stop writing it that way. Write it this way, okay? So it's just saying the left side of -3, I'm heading down. The right side of -3, I'm heading up. Okay, we're going to do the same thing for the horizontal asymptote. So every asymptote will have 2 approaches. So we're going to do the same thing for my horizontal asymptote, and we're talking approach. So say on a test, we'll say approach, and this is what we mean. So we want you to write this, the 2 approaches. So 2 approaches always. So here we're going to do, we'll draw this one green, right? And so that's this one, green. So I want to talk about how you're approaching this horizontal asymptote, the one here I just did in highlighter green, right? And you're talking about whether it's approaching. So picture that this is your asymptote. So you're deciding if the function is coming. So you're the dotted line. So the asymptote is the dotted line. So you're standing on that dotted line going, hey, are you coming from above me? Are you looking up and saying, oh, you're going to hit me on the head? Or you're like, oh, you scared me. You came from below me. So I need to know if you're above or below the dotted line. So that's my descriptor, above or below. So then you're going to say limit as x approaches. Now, remember, these guys here are end behavior. So this is end behavior. Okay, so end behavior. A horizontal approach is end behavior of the graph. So that means on the very ends, not the middle. So I'm ignoring this part. I'm looking only at the end parts of the graph. So ignore the middle, and we're looking here and here. Right, so we're looking just at this part and this part of the graph. Very far off and very far off. Not in the middle where things can be happening, over here and here. So how would you approach this? On the left side of the graph, how do you say left without writing left? In math, you would say -infinity. On the very leftish side of the graph, very, very far left of my function, right? And so make sure you put function of my function. It's not the limit of nothing. Right, and I could do a limit of f and then a g, like so later on when we get to calculus, I'll say find the limit of f function, find the limit of the g function. So you have to say which function, right? So that's why you have to put something there. And then how would I say below 0? For math, we don't want to use the words below as much for our concluding. So we would write, we're going to go 0, but for below, a little bit below 0. So for horizontal, as I'm approaching the left side of the graph, I'm approaching 0, but from above. So you're the dotted line. You're like, ooh, you scared me. You're coming from below. And this one was, you're hitting my head. You're coming from above. So for this one, you're going to say limit as x approaches infinity of the function. You're approaching 0. And look, you're going to put a little plus here from above. So this means below. Backwards. Below, whoops, I can fix that to a B. Below, and this is above. All right? So that's how we want to write our approaches for our asymptotes. Yes, question?
So why do we say equals 0 instead of Arrow 0.
This is already saying arrow. So the question is, why can we use equal? The limit is already saying I'm getting close to it but not equaling. So limit already says don't equal. So this is already saying that. My limit as x approaches infinity equals 0. So this is already saying it's approximate. It's not going to equal it.
Okay.
Right? So it's like saying approaches again. It's like, I get it, because you already said it here. It's redundant, so you put my limit equals. Without this, right, without the limit, f of x equals, that's a point. Right? That's a equals. This says approaching. This is the arrow with the limit says I'm approaching it, not going to equal it. So a limit is an approximate, right? So it's like I'm approaching it. It's not exactly equal, but there you go. Okay, does that make sense? So this is already covered. You don't need to put an arrow here because you already covered it here with those words, the limit and the arrow. Yeah. All right. So that's the notation I want you to use with our answers from now on, right? So our approaches. Now, there's also something called a check. So for this graph here, we know what the graph looks like. It's the reciprocal function, vertical stretch by 2, move left 3. We already know nothing's happening. But hypothetically, as we start, not hypothetically, but actually, what happens is that I could have graphs that do this, and maybe go whoosh, and do this. You're like, wow, what's happening here? How do I know if it's approaching from above and below, above, or above, and then maybe it goes through and does this? So then there's graphs that aren't as simple as this. This one, I can write my approaches because I know what my graph looks like. When I start to square things and cube things, then I start to get more complicated graphs. There are going to be maxes and minimums. Do you know what you wish you had in your back pocket? Calculus, because that'll give me my max and mins. Calculus will also give you concavity. So it'll say concave up, concave down, and then you've got so much information when you do the calculus, it becomes redundant. I know the approach because I have the concavity, right? It can't go up and down like this unless I change the concavity. So when you get to calculus and we do these graphs, there's going to be so much information, you're actually going to be redundant on the information. For now, we need these approaches and we need to do a check because sometimes I don't know what's going to happen. Without the added benefit of the calculus with the concavity, max, mins, it is a little vague. So I'm going to show you how to do a check in case we're not sure what the graph looks like. This one, you should not need to check anything because you know what the graph looks like. You should just be able to write your answer. Okay, just write your answer, you're good to go. And so all you're practicing is writing how the answer. I'm going to show you how to do a check when the graphs get more complicated and you're like, I don't know. For instance, the last example, so we're going to do 2 and 3. So this is 1. We'll do 2 and 3 today, I think, yes. And then, so we'll do 2 and 3. One of them, which I'll do in a separate video, I do something like this. So I go and I purposely did something that was vague. Here, yeah. So there's a horizontal asymptote, there's a vertical asymptote, and there's a dot. And you have nothing else. And you go, I have no idea. Right? So I don't know if this is supposed to be heading down or is this supposed to be heading up. Does this go down and under? Like, no idea. There's so many variations of things. And then I don't know if it's here or here because I gave you no information. Right? Once I did something like this, so if I did this and I said there's an x-intercept here, then I know it does this, right? So once I give you, but on 2 of them, the last 2 that I do in this series of examples, I gave you something where, you actually have no idea what's happening. So you do have to do a check, right? Where I give it too vague. The next one we do, we'll have enough information, but as we kind of, the last 2 here. So I'll do 2 in a video, right? So I'm going to pause the video in a second. I'll do 2 and I'll do 3. In a separate video, I'll do this one. And then 4 and 5, or 5 and 6, and some of them are going to be like you don't have enough information to graph it without doing a check. So that's where the check is useful. For this one, I wouldn't check. You can just write your approach. And I'll show you what check means in a minute. So if you're like, I don't know what you mean by check, I'm going to show you in a second. Okay, so that's good. I'll stop the video here.